Okay, so this is the first video in my series on quadratic equations that I'm going to do over the next few weeks. And as it says, we're going to try to understand what, first of all, is a quadratic equation. So to do this, I'm going to talk about first linear equations. Now, linear equations would be the first type of equation that you would have come across. So, for example, let's imagine we had 2x plus 5 is equal to 6. Maybe, or we could do 6 minus x, perhaps. So, the way that we solve these equations, let me just write this linear equation. The way that we solve linear equations are we collect the terms, don't we? So we put the x's on one side and then we put the numbers on the other side. And then we'll have a certain number of x's is equal to a certain number. Then you can divide both sides by whatever amount of x's there are. And then you've got the answer as 1x equaling whatever it is. So solving this problem, solving these equations, depend on collecting like terms. So this 2x is like this x, or we could say this negative x. I like to think about 6 minus x as the same as 6 plus negative x. And then we've got the 5 is like the 6. So what we're going to do is we're going to collect let's just collect the terms then. So we'll say, we'll maybe minus 5 from both sides, and that'll give me the 2x on the left. So we've minus the 5, so it's disappeared. But we need to minus it on the right-hand side as well. Maybe I'll leave the equal sign in the same place. And so we still have this. In fact, what I might do is, I know, I'm going to just collect these so we can still see the colours. So I've minused it on the left-hand side, so it's no longer there on the left-hand side. And I'm going to also minus it on the right-hand side. So minus and minus 5. Okay. I'm then going to add x to both sides, but by adding x, it cancels out the takeaway x, or cancels out the minus x. So that's why I'm choosing to do that. So let's first of all just copy out the left side as it is, and then I'm going to add x. So that's right, add, and then we will add x. And then on the, so that leaves just with 6 minus 5 on the right-hand side, which we can actually just calculate now, which is going to be just 1. And we can add these two together as well, and that was going to give me 3x. So we've got 3x on the left, we've got 1 on the right. So we've collected all the terms, all the x's are on one side, all the numbers are on the other side, and as I said, now what we do is we divide both sides by this number here, which we can call the coefficient. Let's learn some keywords. So we divide it by that, and then we end up with x is equal to 1/3. So this is, as I said, this is a linear equation, and it's because it's a linear equation because if you were to plot this onto a graph in some way, for example, if we collected it all over here, or either side of it, we could say y is equal to 2x, or y is equal to 6 minus x, or we could move them all together, and we would always get a straight line. So think about line from linear. And the other sort of main thing to realize is that all the x's are to the power of 1. Okay, if we just have just x, then it's to the power 1. So the variable, in other words, the unknown value, which we just label with a symbol, x, it could be any letter though, it could be A, B, C, Y, X, W, Z. Anyway, the power is always 1, okay? There's no higher power than that, and there's no negative powers either. Okay, so that's a linear equation. So the next one up is the quadratic equation. So I'm going to just, I think I'm just going to, just erase all of that and just keep the original equation. Maybe I'll leave the powers of 1 there. But we know we don't normally write power of 1, but I just wanted to highlight the fact that the power is actually 1. In other words, when we write any number or any letter 3, it means 3 to the power 1, but we don't obviously write the 1 there. So the next one up is a quadratic equation. Let's this time, so basically we've still got the x to the power 1, so it could have 2x plus 5. So far this is just an expression because I haven't said what it's equal to. But we could also have a certain number of x squares. And these pluses could be minus as well, if we like, doesn't matter. The point is the maximum power now is 2. So we call this, and actually this would be a quadratic expression. And if I said it was equal to something, for example, 3 or 3x or whatever, we call it a quadratic equation. So actually, again, continuing with learning the language, if I didn't have any equal symbols here, we would say that's a linear expression, that's a quadratic expression. But because I've said it's equal to something, then it's a linear equation, a quadratic equation. So let's have them, and this will make a little bit more sense later on, but let's say that they're all equal to 0, because I could obviously put everything on the left-hand side of an equation, and therefore leave 0 on the right-hand side. So from now on, let's just imagine I've arranged it so as all the stuff is on one side, and we've got 0, nothing on the other side. I want to just show you actually why this is very different to the linear equation. It's because this is just like that one. Well, it's identical to, in fact, as that is identical to that. But if it was another number, then we would say it's like that number, and that's like that number. Maybe I should change it just so to emphasize that point. So let's say it's 7, and that's 4x. So the 7 is like the 5, the 4x is like the 2x, but the 3x squared is not like either of them. In other words, I can't collect the terms. So this we cannot solve in the way that we solve the linear equation. Because if I collected all the x's on one side and the numbers on the other side, I wouldn't be able to do much further, much more than that, really, actually. So we need to use a different method to solve the quadratic equation. That's what I'm going to start to look at in the next few videos. But this video is really just understanding the overall picture of what is a quadratic equation, and I wanted to show you that it can't be solved in the way of a linear equation. So just give you an idea of how these continue. You would have the next one would be called a cubic equation. And you might have guessed how that one's going to be different. It's going to be a certain number of x cubed. So it could be, I don't know, 5x cubed, and we could have 2x squared. By the way, we don't actually have to have all the other things. So we could miss out a number of x's and just go straight to the numbers. And we could say that's equal to 0, but we don't have to. We could have stuff on the right-hand side. We could have is equal to 4x, maybe. It doesn't matter, but I'm just writing it at the moment so they're all equal to 0 on the right hand side. I just want you to realize that it doesn't have to be that way, but it could be that way. So let's highlight these in the same way that we've been highlighting the other numbers, the other terms. These are all called terms. Terms are things that get added to one another within an expression. And remember, an equation would have an expression on the left and something on the right, equal to something on the right, which could be another expression. Okay. And we'll have to color code this as something else again. So I could carry on. I could go to x to the 4, x to the 5, and blah blah blah. We're interested in for this video. We're interested in this one here, quadratic equation. So a quadratic equation is an equation that has a power of 2 in the variable. It could have power of 1, it could have a number, but it doesn't have to. The point is the maximum power is to a power of 2. None of these have a power of negative, any negative powers. And I just wanted you to realize in this video that we can't solve these quadratic equations in the way that we solve linear equations. It's very important actually to realize that. So perhaps before I wrap up the video, I want to just emphasize that a little bit further. Let's rewrite that one, maybe in a different color. And if we try to solve this this equation using our tools from our linear equation work, we will see that it's impossible. So what I would do first, if I was going to solve it in the way I solve linear equations, is I'd minus the 7 from both sides. That leaves me with 3x squared plus 4x is equal to negative 7. Now, this is when people invariably make a mistake, and they might try to collect these terms even though they can't collect the terms, and they might say, for example, 7x squared is equal to negative 7, and go, oh cool, so that means that x squared is equal to negative 1. Actually, in this particular case, you're going to have a problem, because you can't, no square number becomes, nothing squared becomes a negative number. Well, that's beside the point. Anyway, point is, when I went from here to here, I made a mistake. That's not how you do it. So we need a new method, and I'm going to talk about a few different methods that you can use to solve quadratic equations, but most important thing to understand is you cannot solve them the way that you solve linear equations. Okay, all right, that'll do for this video.